Hi friends, welcome back to the channel. Thank you very much for subscribing to this channel and liking the videos. It's making our channel very familiar. So today I've got this inverter. It's a 5-star WO8548. So what's the problem with this inverter is that there's a short on the battery terminals. So this is one of the faults that we repaired before, but you will never know. Maybe today we're gonna find something. So when I measure on the battery terminals here, let me just measure, you will see the resistance on the meter there, it goes down to 0 ohms. And the inverter is not switching on, you can see there. Check the battery terminals. You can see the resistance goes down to 0 ohms. You see they have got 0 ohms. And I'm measuring the battery terminals. There. You can see I've got 0 ohm. So I have to open it and see what could be wrong. And then we can try and fix this inverter. But most of the time when the inverter fails like that, it damages the low voltage Mosfet, and also sometimes it damages the output stage, which is the IGBTs and other things. So what we're gonna do now is to strip this inverter, and then we can go down to the power board and see what's happening there. Let's strip it. So now these guys, they use the glue to make the contacts very strong so that they won't come out easily. But now it's problem for maintenance, because if you have a glue like that, the process of taking it out, it's not easy. You see this glue there? So this glue, it makes it difficult for us to remove, because if you pull it out, obviously you can damage the plugs. So we have to use a hot air station so that we can remove the glue. Without that, we're gonna end up having too much job. So here's my hot air station. Just hit the inside on the plug where that I want to take out. Okay. So this is our charge controller, MPPT charge controller. So these are the IGBTs that controls the charging voltage. So it's connected to this coil so that it can regulate the voltage. You can see that this coil is coming straight to the IGBTs there. Let's move on. Okay, now we are going to check the input stage. Remember, these are your input MOSFETs, these ones. All of these small ones, they are your input MOSFETs, this side. So obviously, here there's a short. And also we have to check the output IGBTs. Because if you turn the board like this, you see what I mean? See, this heatsink is for low voltage. So what's happening is all of those MOSFET that you see there, they are going to change the low voltage 48 volts to 400 volts there with the help of this transformer. So on this side, we are going to have the IGBTs that changes the 400 volts to AC. So these are the IGBTs that we need to check. Those ones. These are output IGBTs. And there's another subscriber, he asked, how does the off-grid inverter charges the battery? I'm going to explain now so that you can understand. This is the way they work. You see these IGBTs there? These are output IGBTs, as I've just said. They change your high voltage 400 volts to 230. So these ones here, they are for charging. See these ones there? They are for charging. So what's happening is when you connect your AC there, it goes direct to these IGBTs. Then it will be fed to this transformer. You with me? Then it's obviously at a high frequency. So this transformer will change that 230 volts to a lower voltage, which is 48 volts. So these MOSFETs, again, they act as rectifiers. So they will rectify that AC that's being generated by the IGBTs at high frequencies. And then the capacitors will then smooth the voltage. Then it can go back to your battery and charge the battery. So that's how they work. So with these inverters, they can only work one way. What I mean is you cannot charge while you are drawing power from the battery. It's impossible. Let me explain so that you can understand. We've got one transformer here. So this transformer cannot change the voltage from 230 to 48 volts while it's changing the 48 volts to 230. I think that's clear. That's easy to understand. So there's no way that you can charge the battery while you are draining power from the battery. So we've got a short on the battery terminals. You can see there's a short. Okay, let's check our low voltage MOSFET. All of those MOSFET we need to check. So the easiest way is to check the gate and the source. Let's check. See, this one is looking alright. 0.6. Okay, let's use the resistance. It's much easier that way because we know if it's not 11 kilo ohm, I think it's 4 kilo ohm somewhere there. Let's see. Oh yeah, it's 11 kilo ohm. So this channel is okay. The second one is okay. The third one, 87 ohm. So this third one is a problem. The fourth one, 13 ohm. So these two channels are not right. So what's happening is with this MOSFET, you saw I didn't check all of them. I just checked by pair because we've got 4. Just zoom out a little. You can see here I've got 1 pair, 2 pair, 3 pair, 4 pair. There's 4 pairs. So I only check 4 because these MOSFETs, it's actually one MOSFET, but they combine them to make one large MOSFET. So if I have a short here, it means that all of these MOSFET are not right. and also, so I've got these two pairs that I need to change. So I have a total of 8 MOSFETs that I need to change, and also the IGBTs. Let's measure the IGBTs. Between gate and okay, you can see there's a short there. Okay, so on my side, once I've got a short on one IGBT that's going to the output, I replace all 4 IGBTs. The reason is some of the IGBTs, they can get damaged and you can't see. There's another inverter I've been trying to fix, and I replaced only the ones that were shorted. But the moment I switched on that IGBT, because it was damaged internally, it blew again. Then it damaged more components. So the best way is to do what is to change all 4 IG. Once there's a short on the output IGBTs, just change all 4. It's best that way. So we can leave this last one because it's not for the output. You can see this track here. This is a DC bus, comes into the IGBT. So these 4 are going together. So these ones we have to change, all of these 4 IGBTs. I'm going to change them now, and these 8 MOSFETs, then we will see how it goes. Let's do that now. You see what I mean when I say we have to change all of the IGBTs. You see, this one was not having a short, but you see what happened there? It popped out. See there? It looks like there's no short, but it's open circuit. So what's better? Better change all of them. That's how we do it, because if you change some, sometimes you might win, but it's not worth it. Imagine you change the damaged one, then you blow something. That's not gonna be nice, because you're gonna have more job rather than just changing all 4 driving IGBT, because these are the most important IGBTs on output. So we're gonna change all 4 of them. Okay. Okay, there are the IGBTs, all 4 of them are out. Okay, I was just opening the holes. So let's go to the low side. Okay, we have to remove this channel. Yeah, let's remove all 4. Okay, here is our low voltage MOSFETs, 8 of them, and I have to change this. You can see the 8 MOSFETs and the 4 IGBTs. Let's put new ones. Okay, but before we replace the MOSFETs, let's check now if we still have that short circuit, because from our testing it showed us that the last MOSFETs were the problem, the 8 MOSFETs. Okay, let's check if there's a short. Okay, there's no more short. You can see now it's charging the capacitor. You know the reason why it starts from low resistances, because the capacitors are not yet charged. It will do that until the capacitors are full. So it's open circuit. When it starts charging like that, it's okay. It's not the same as before. You remember it was just like this, like as if you joined the wires. It was not charging or anything. But now it's charging. You see now we've got 7 kilo ohms. So that's good. That's good. So let's change the components. Okay, we're gonna start with the MOSFETs. We need 8 of them. So okay, here we are. We've got 8 MOSFETs. But we need to bend them a little bit so that you can see the new one is straight like that. So we have to bend it so that it can go on the points there. Because you can see that the middle pin is not aligned with the 2 pins there. So the middle one has to go a little bit back. So that's what we're gonna do. Back. You can see now it's bent, and then we have to make it a little bit straight so that it can go just like that, just like that. So we're gonna do the same thing on all the MOSFETs. Okay, let's flip it. Okay, the low voltage MOSFETs are in. Now let's go to IGBTs. We need 4 of them. I've got the 4 IGBTs. Let's change them. Okay, I'm done with the soldering. Let's cut the legs. You can see that these legs are long. So I have to cut all of those legs, see these ones and these ones. I have to cut them. They're too long. So the reason why I'm closing here is because I don't want them to jump all over. I want them to throw them in the bin. Otherwise we're gonna have lots of cuts here. So there's the off cuts. Gonna put them in the bin. Okay, now we have to put back the capacitor. So the reason why we took out these large capacitors because we wanted to access the IGBTs. You can see that it's on the way there. So it sits there and we have to take out this IGBT, so it's easier to remove it and do a proper job. Okay, one thing before I forget. So if you want to buy these IGBTs, I will put the link on the description. If you want to get them, we have a whole lot of IGBTs with different current ratings and all that. So if you want to buy, and also the MOSFETs, we've got a whole lot. This is just few of them, but we've got a lot of this. So if you want to buy MOSFETs or IGBTs, I will put the link on the description. This is a 5 kilowatt inverter. I will put the link for the 5 kilowatt MOSFET and IGBTs. And also I've been battling for many times with the soldering pump. You see this one, I bought it some time back, but it didn't last long until I found another supplier who gave me a better the soldering pump. You see this one, if I hold here, it's no longer having much vacuum. . Okay, you see it's just moving. If I block here, it's just moving there. You see that it moves up until, so it's no longer having enough vacuum. Although even if it was new, it was not having much vacuum until I got another supplier. They supplied me with this one. This one is a very nice desoldering pump. You see when I hold close here, look there, it's not going all the way, but when I leave, it's going. So it has got much suction power. Let's look there, I block there. So this one is a very nice desoldering pump. It makes jobs easier. So if you wanna get one, you are more than welcome. It comes with the extra tips there. So I will put the link as well if you wanna buy this desoldering pump. It's a very nice desoldering pump. You saw when I worked there, it was just flowing. So it's a very good for inverters. You can see, just take a look at this hole there, how it sucked. You see, perfect. It's a big hole, but it sucked very nicely. So if you want to get it, more than welcome to buy it. I've got the link on the description there. So I will put the link for the Mosfet and the IGBT and the desoldering pump. Let's continue our job. You can see the capacitor just fits. See there, it fits nicely. I don't have to like do some wiggly yeah, to hit it or anything. You just solder, then you're done. It's very convenient, and then I really like it. It's the first pump that I had for some years. I've been battling with this, but this one is very nice. Okay, alright, what's next now? Before we fire this inverter with some power, we have to check the resistors there if there's no damage. But I see that there's damage there. There's one resistor there, it's damaged. Let's take it to the microscope and do some analysis. Okay, you can see that my microscope, it's on the IGBTs. So I saw one resistor there was not right. So what I will do, I will check and see which resistors is not giving the right value, and then we can change the optocouplers as well, because you see these ones are optocouplers. Once there's a short on the resistor or open circuit on the resistor, the optocoupler can't survive. We have to change the optocoupler as well. Okay, here we are. That's the resistor that I saw before even doing some measurement. You can see that this resistor, it's same value with this one. It's a 47 ohm resistor, but there's a burn mark there, so that resistor didn't survive. So let's measure. This is the obvious thing. Check the multimeter there. You can see 24, 47 kilo ohm. It's wrong. This is not a 47 kilo ohm, it's 47 ohms. 47 R0 is 47 ohms. And this one, when I have to change it, because you can see 47 ohm also, that is reading kilo ohms, not sharp. So let's look at the other IGBTs, because we've got 4 IGBTs. You can see these ones, they look clean. Yeah, there we go, 47 ohm. 47 ohm. So this first IGBT is okay. This second one is the one that we've just checked, is not okay. The third one, there we go. So the IGBTs, you see these big pins there, these are the IGBT pins. You can see they go to that resistor there. So this second IGBT, let's check the resistance. I mean the third one. The second one is gone. 47 is okay. .47 is okay. Alright, let's go to the third one. So these are the IGBTs that controls your output. So these resistors, they supply the gate voltage. So you'll get 15 volts when the IGBT is on. Okay, let's check the last one. Oh yeah, the last one, we didn't change it. It should be okay. So this one is not connected to the output. Alright, that looks good, except one. Let's change the resistors and change the optocoupler. Okay, which optocoupler we are going to change? We just follow this. Okay, what we will do is just follow this track, this one, where it goes. Okay, which Mosfet is it? Which is not this Mosfet, the optocoupler, and it's not this optocoupler, the third one. There we go. So this one, this Mosfet, I mean this optocoupler is the one that drives the one with the damaged resistors. You can see, let's see, there is the resistor there. So one pin goes there, oh, is this one there? It goes direct to the third pin there. So that optocoupler we have to change, and the driving resistors. Let's do that. It's the third optocoupler. I'm sorry, my hot air makes a little bit of noise, so just be ready. I'm gonna make some noise now. Okay, let's go. Yeah, I don't mind the color. It's just that this one is a high voltage rated optocoupler, the white one. So I prefer this one because of the high voltage capability. So this is what TLP352. So I prefer using a soldering iron instead of hot air, so that you can have a proper contact. With the hot air, sometimes you think it's in while it's not. Okay, now is the moment of truth. We have to test this inverter. Anyway, this is the inverter that we've been busy with it. You can see we've changed the optocoupler, the driving, the IGBT, the Mosfet that side. So let's test it. Let's see what's going to happen. Let's hope for the best. Okay, there is our display here. Okay. Alright, I think the best thing is that we also measure the AC coming out if the inverter works. Let me put the multimeter close so we can test if the inverter is giving the correct readings. If it works. Let's see. Okay. So the fans are now spinning. There we go. You can see we have 230 there. Okay, let's check with the multimeter. Ah, that's nice, eh? That's very nice. Let's check. These points are out. This is our output. You can see there 229. Same as what we are getting there, 230. So we're done with the repairs. That was our job for today. Hope you liked the video. Hope it helped you. Hope you've learned something. Thank you very much, and I hope to see you on the next one with some more interesting things. Thank you very much. See you again.